Hello. Here we have a 3-inch scale bowl traction engine made in 1985 using the Plowstow design. This is a recent addition to the workshop, so I've decided to make a playlist of videos dedicated to showing you the journey of owning a steam engine. If you are interested in steam, this will provide you with an idea of what is involved. I've been doing a few tasks to tidy up the engine, and I've noticed that the regulator has a fairly bad leak, so my plan in this video is to take it apart and investigate. My plan was to clean the regulator to help it to seal, and while taking it apart, the grub screw holding the rods to the valve stripped its threads. I'll make a new part to replace this. This is what the part looks like. There isn't a lot of material there for the threads, which is probably why they failed. So probably need to make this slightly taller and thicker to deal with that. I'll use a slightly smaller grub screw. However, it still needs to be a easy sliding loose fit in this part, so that the regulator still operates correctly. I have a bit of phosphor bronze here, and I think that's big enough to cut the same part out and keep it a little bit tall, make it a little bit taller as well, which should assist in giving it some more threads for the grub screw. And I'm going down to an M3 thread as well, just to give it a bit more meat to grip on. I have the piece of round stock in the vise in the milling machine. I will mill the end to a rectangle shape, leaving the other end as a cylinder. This will allow me to hold the part in the lathe and accurately part off to the correct width. Here is the progress so far, shown with the original part next to it. I have made the part slightly taller, as previously mentioned, to enable more threads for the grub screw. I will drill and tap a hole for the grub screw. The hole for the rod will be done last after parting off. I cleaned up the end of the part while reducing down the size to enable the grub screw to remain in the middle of the finished part. It is then a case of parting off to the correct width. So the plan now is just to part this off the width. See if we can take a measurement from that small cut. Can do it a little bit thinner. There we go. This is all we've got so far. So the original there, and the replacement of the hole for the grub screw. Roughly the same width, slightly taller. Fits in there nicely. there's room to move. We can always sand that and give it more clearance if needed. So the next and last stage should be to drill a hole in it. So I'm going to go ahead and mark that up, and I'll probably go ahead and do that on the drill press, and then give it a trial fit, and we'll see how it looks in the engine. I tested this and the result was that it was even worse. The regulator fully closed would still have the engine idling at a slow speed, whereas before it was just leaking out of the drain cocks. So I've taken it apart again and set up the slide in the mill here. I think what I'm going to do is just take a skim, like as smaller skim as possible off that. I did think about sanding it and lapping it on a flat surface, but because the part's so small and awkward shape, I think that I would end up putting pressure onto one side or the other as I sanded it, leaving it to be like a bowl shape, and really that needs to be flat to start with. So I think this is the way I'm going to go. I've marked the slide up with some black pen, and I took a very light skim cut, and as you can see it's cleaned up in the middle there, in this middle spot, which sort of proves that was the high spot, which would therefore let air in around the edge. So that's definitely part of our problem. And I'll get this cleaned up and then we'll move over to the mating surface. I've made up this block which I've milled flat and stuck some sandpaper to, and then in here we've got two holes in the corner there, which is where pressure comes up from the boiler. So I've blocked those off because I'm going to be sanding inside here and I don't want any grit to go down in the boiler. And I've blocked the hole off there that goes to the valves. So the idea is I'm going to put this in here, and I've just put a hole in the very top there. So I'm going to put probably a hole punch or something in there and use that to slide this back and forth to sand the high areas and clean up this to get it as flat as possible. I'll start with a fairly coarse grit and then work my way down. That's just in the middle there, just to try and prevent it from biasing the forces and making a sort of a bell shape. We want to try and get this as flat as possible. No idea if it's going to work, but there's one way to find out, right? Let's do it. So I've done a lot of different grades of sanding on that, and it seems to have cleaned up quite nicely. There's a lot of pitting, which would take a lot of sanding and material removal to get out, so sort of compromised where I think it looks flat enough, and I'm hoping that the brass slide, being a softer material, will wear into any inconsistencies here. So now I've got to clean it up and then reassemble it. So here we are on test. Here we are testing it. We've got 75 psi. The safeties are lifting slightly, although the max is about 100 on this. They lift early, which is fine. So we've got the regulator fully shut, and we're in mid-gear with the drain cocks open, and we can see we have got a bit of steam coming out.
but it's much better than what it was. It used to turn over when it was closed on 30 psi, and doesn't have enough leak to drive itself with the regulator closed at 75. So I would say that the two surfaces need to sort of wear in, like bed in against each other, so maybe the seal will get better over time, but that's more than acceptable from my point of view. So I would say that's fixed, so good news.